Oh, Algebra 2, welcome. This right here is something that Mr. Gubido and I have been working on for quite a while. This is the newest version of it here. We're going to call this one CFR4, Graphing Transformations on Functions. This is the guided notes for that. You have already done the describing transformations, and if you haven't, you probably should do that first. This is directly related to it, and especially you need to have done the parent functions packet, or at least have gone back and looked through my version of the parent functions packet, or our version here. So let's go ahead and take a look at this business. We've been doing this already in terms of we can describe the transformations of this stuff right in here. This 2 times the quantity x minus 3 squared plus 1 at the end. We've already been doing this work, but now we're going to take it a step further. We've described it. We know that that's a vertical stretch and right 3 and up 1, but now I need to show you how we're going to graph it. So here's where that parent function packet comes into play here. Step 1 is to identify the parent function and critical values from the parent function worksheet. Place them in their columns. There's a reason we've done our critical values, because I'm going to first I need to figure out what my parent function is, and then I need to place them in the correct spots, the critical values. I see something that's squared. So something squared indicates that our parent function is going to be our x squared. I'm going to put a little note to myself that this is x squared. And if I look, I'm going to put the critical values here of the x squared here. So -2, -1, 0, 1, and 2. And in x squared, we're going to square those things, the y values, the f of x values. That gives us 4, 1, 0, 1, 4. Okay. We've figured out our parent functions. We've got our critical values. That is step 1. Step 2 says determine the horizontal stretch compression reflection value and put it in the correct box. So horizontal would be anything that's being squared, anything multiplying on the inside of those parentheses that's being squared. And in this case, we don't have a value that's going to stretch or compress or reflect in a horizontal way. So we're going to call this 1. We're going to call this value 1. You'll see why it's in a second. Okay, 1, because it's not stretching. It's not less than 1. It's not compressing. It's not greater than 1. There's no reflection. It's not negative. So it's just multiplying by 1. Now we need to put our horizontal translation in here. So this was times 1. This was x minus 3. X minus 3. So we've got our horizontal stretch compression reflection value, which was just 1. We've got our horizontal translation, which was, I'll throw in here x minus 3. Why not? Okay. Now we need to put our vertical values in. So that was steps 2 and 3. Step 4 says determine the vertical stretch compression reflection value and put it in the correct box. What is multiplying on the outside? What is multiplying on the outside? Well, that value is 2 times 2. Yeah, we'll keep that as minus 3. Why not? I'll show you why. That's step 4. Step 5 says determine the vertical translation value and put it in the correct box. This says plus 1. Plus 1. Okay. We've identified all the values that we need to know, right? We've identified all the values that we need to know. This 2 went here. This 1 went there. This x minus 3 business went there. And since there's just kind of 1 multiplying, this kind of went here. So I'll draw that arrow. But that's where we're bringing these values from. So how are we going to use those? That's a really good question. It's a really good question. Remember, we're trying to graph the transformations. How does this look different from x squared? And what we do is step 6. It says perform the exact values, the exact operations from the vertical values. So notice how this said times 2. We're going to multiply these values times 2. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2, once again, is 8. So we did that one. We took those and multiplied those by 2. And now we also have to do the same, the exact operation from the vertical value. So for my translation, I'm going to add 1, add 1, add 1, add 1, add 1, which would give me 9, 3, 1, 3, and 9. What we have just found is the y parts, or the f of x part, of the critical values, the transformation that we're making from them. Interesting. In fact, they're so important, I'm going to put them in a different color. 93139. Step 7 is where things get a little interesting. Because it says perform the inverse operations from the horizontal expression. The inverse operation from the horizontal expression. So this is interesting. So here we're looking now in these boxes, in this box first. We said it was 1 times all this, but we need to divide. We need to do the inverse operation. The inverse operation of multiplication is division. So we're going to divide these by 1 and divide these by 1, or we'll just do it like this. Divided by 1, divided by 1, divided by 1, divided by 1, divided by 1. Well, here's the thing though. We know that dividing by 1 does what? It just keeps it the same. So this is still -2. Let's go ahead, different color here, now that I've seen that. Sentiment still holds. So what we're going to do is divide these by 1. -2 divided by 1 is -2. -1 divided by 1 is -1. We get 0, +1 and 2. 1 divided by 1 is 1, and 2 divided by 1 is 2. So we've done the inverse operation. The inverse, this says it's -3. That's x minus 3. So if we do the inverse operation there, the inverse operation, again, inverse operation of subtraction is addition. I'm going to add 3 to all of these. And I'm going to get, well, -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And 2 plus 3 is 5. So here's what we have right now. I have, at my disposal, I have my parent function values, my critical values. I'll put those right here. Those are my x and y's. And now I have the translated values, the transformed value. It's not just translated, sorry. The transformed values, okay? I have right here the new x and the new y. That's exactly what we call it, the new x and the new y. So we're going to graph these on the same graph. We're going to graph the parent function, the x and f of x, and then we're going to graph the new x and the new y, or the new f of x. So let's go ahead and do that. I'm going to do the parent function in green. We'll do this in green. And we've got, it was -2, 4. Oh yeah, that's not going to work out well, is it? Here we go. I've got -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And if I graph that, that graph looks something, let's try that again. Looks something like this. This is my parent function. I put it in purple, my parent function. Now what we have to do is graph the transformed function, And it might not stay on the graph, but that's okay. We can sketch it the best we can. Again, we're not trying to go for exact, we're trying to go for sketches at this point. So we're going to graph now 1, 9. So my new values here, my new value. So my new function, my g of x. I've got x and y values here. My x values are 1, 2, 3, 4, 5. And the y values that go along with it are 93139. So we're going to graph 1, 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 2, 1, 2, 3. 3, 1, 4, 3, and 5, 9. And let's go ahead and sketch this guy. Interesting. That is our g of x. And we put that in a different color. Yeah, I know, it's close enough. Down there, close enough. Okay. And so we have just transformed. We've taken those critical values, and transformed them into new values to point. And so here's the thing. This is what the beauty of this is. We're just taking 5 values, and those transformations, that will help us get our shape. Notice how, excuse me, I've drawn this very poorly, but I at least have an idea of what's going on because I've sketched those 5 critical values. I've transformed those critical values. Now let's see some things that are interesting. Let's go ahead real quick and look at this bottom stuff. So let's see if what we graph makes sense. So I'm going to do this here. I'm going to check. Oh, I forgot to. Was that negative? Oh, wow. That one says negative. This is a positive 2, guys. That's a positive 2. Okay. Positive 2. So let's see if these all make sense here. Let's see if all these make sense. We said, if we were thinking of our CFR3 stuff, that 2 multiplying out front would be a vertical stretch. So it should be taller. We said something should go right 3. And something, it should go up 1. A vertical stretch, right 3, and up 1. Well, let's take a look here. Does the green graph look narrower than the purple graph? Yeah, we've stretched it vertically. Also, let's take a look at that vertex. My vertex started here for my parent function, and it ended up over here for my transformed function. It went right 1, 2, 3, and then up 1. We did it. It went right 3 and up 1. Okay, that's a lot. That's a lot to take in. I know it is. Okay, that's why you'll see that there are 3 examples that I'm going to do, and then the 4th one I want you guys to do. Okay, that's a lot to look at. Let's look at another version of this. Okay, let's look at another example. But notice how our graphing matches what we did down here, our descriptions. It's like I planned that. Well, it's like math planned that. I didn't plan that. That was planned well before I got here. Okay, let's look at this. Let's look at this again. Okay, let's look at this again. That's a lot, I know, and that's okay. Let's go through this step by step another time. Again, we're remapping those 5 critical values, or however many critical values, depending on the function you're working on. But we're remapping those critical values. Step 1 is always going to be identify the parent function. And if I'm looking at this, I have -½ times the absolute value of, oh, hey, we already figured that part out, right? Times the absolute value of ½ times x plus 1 minus 3. Our parent function, we saw these vertical lines, these vertical bars here, and we know our parent function is the absolute value of x. And if you take a second to go back to your parent function packet, you will notice that the critical values for the parent function of absolute value, -2, -1, 0, 1, and 2. And that corresponds to, well, the absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So now we've got our parent functions. We've done step 1. We found our parent function. We put the critical values in. Step 2, determine the horizontal stretch, compression, reflection value and put it in the correct box. So let's see. In this case, I've got this ½ multiplying. Again, we're looking on the inside of the absolute values. There's something multiplying on the inside, and yes, there is. We have it's being multiplied by ½. That comes from this ½ right here. That negative half on the outside, we'll deal with that later. We'll deal with that later. Okay. Then the other part says it's x plus 1. X plus 1. Okay. Okay. X plus 1. That was the horizontal value. Step 4 says determine, oh, that was steps 2 and 3, sorry. Step 4 says determine the vertical stretch compression reflection value and put it in the correct box. Is there something multiplying out front? Yes, it's being multiplied by negative half. It's being multiplied by negative half. And do we have a vertical translation? We sure do on the outside. It's saying it's going down 3. Oh, I'm sorry, minus 3. It means down 3, though. We know that. We know that. So we've taken care of steps 4 and 5. Here's where it gets fun. I like to do the vertical first because it makes the most sense. It's what you're supposed to do, it feels like. I'm going to use the exact operations from the vertical values. 2 times negative half. Well, 2 times negative half is negative 1. 1 times negative half is negative half. 0 times negative half is 0. 1 times negative half is negative half. And 2 times negative half is negative 1. Okay, I like this. Again, we're multiplying everything by negative half. And now we said we're going to subtract 3 because we're doing the exact operations. Negative 1 minus 3 is negative 4. Again, we're going to subtract 3 all the way down. Negative half minus 3 is negative 3.5. 0 minus 3 is negative 3. Negative half minus 3 is negative 3.5. And negative 1 minus 3 is negative 4. So now we've taken care of our new y values. We've translated how the y is going to work, but now we got to figure out the x component. How is that going to work? And step 7 says perform inverse operations. Perform inverse operations. Inverse operations. That, as I'm looking right here, I said on the inside, I said we'd have multiplied by half. So we're going to do the inverse operation. The inverse operation. It kind of makes sense though, right? Because that whole horizontal thing is all goofy and backwards anyway. You know, we know that this, outside that multiplying by half would have been a vertical compression, but inside it's a horizontal stretch. It's backwards, right? Just like x plus 1, we know that's 1 unit. We know that's 1 unit left, right? So we're going to do the opposite thing. So I'm going to divide by half. When you divide by a fraction, you actually, it's like a number divided by a fraction, you flip the fraction and multiply. You invert and multiply. So in reality, I'm multiplying by 2 over 1, or that's 2 over 1 is just 2. So I'm actually multiplying everything here by 2. And if I do that, negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 0 times 2 is 0. 1 times 2 is 2, and 2 times 2 is 4. So we've taken care of the first box for horizontal. Now we need to do the second box. It says we were adding 1. It's x plus 1. But if we're doing the inverse operation, what's the inverse operation of addition? And you would tell me, subtraction, Mr. Braden. And I'd say, yeah, there you go. Way to go, subtraction. So we are going to subtract 1 from all of these values to get our final new x value. And if I do that, negative 4 minus 1 is negative 5. Negative 2 minus 1 is negative 3. 0 minus 1 is negative 1. 2 minus 1 is 1. 4 minus 1 is 3. So what columns am I graphing? Great question. Once again, you have your parent function. That's right in here. These x values and these y values against your transformed function, which happen to be these x values and these y values. So xy of your old and xy of your new. Let's go ahead and do that. Parent function, we will once again put in some purple. The parent function, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Don't just stop it there. Draw it all the way out. There we go. That's our parent function. Okay. Now we need to graph our transformed function, I don't know what I call this, k of x, g, m, l, k of x. K of x looks like this. We said we have -5, so let's write this. K of x was going to our x values and our y values here. We had -5, -3, -1, 1, and 3. And then we had -4, -3 and a, whoops, -3.5, -3, -3.5, and -4. So let's plot those. -5, 4, 1, 2, 3, 4, 5. Oh, it's -4. 1, 2, 3, 4. Then we had -3, 1, 2, 3, -3.5, 1, 2, 3.5. Then we had -1, 3. Try that one again. Then we had 1, -3.5, and 3, -4. Whew, that's a goofy looking one, right? Let's do this here. What happened here? What happened? This is our k of x. What happened? Did what we say was going to happen actually happen? Well, let's look. Let's look at this thing. Okay. If I look here, does what you graph make sense? Let's check and find out. This negative multiplying out front, we'd call that a reflection over the y-axis. That is a vertical reflection. That half multiplying here, that would be a vertical compression. So it should have gotten a little skinny. Like if I'm compressing vertically, it's going to get a little wider. On the inside, this half multiplying in here, this is a horizontal stretch. So I'm taking it horizontally and pulling it wider. So not only I had to compress it to make it wider, now I'm pulling it and making it wider. So it's super wide now. We have x plus 1, so this would be left 1. And we have -3 out here, so this would be down 3. Let's check our vertex, that kind of central point here. Did that go left 1 and down 3? Left 1 and down 3. Hey, it did. We got that one. Did it reflect over the y-axis? Yeah, because it's now opening down. Okay, it's now opening down. Did it compress and stretch? It sure looks like it, because it's a heck of a lot wider than what it started with. Look at that thing. Look at that. Compare that blue to the brown. That is a lot wider in the brown compared to the purple. So it does look like we compressed it and we stretched it horizontally. We compressed it vertically, stretched it horizontally. There we go. Okay, one more. Let's take a look at one more here. One more example, then I'll have you guys do one. Okay. Last time, a little quicker. We need to, number 1, find the parent function. I see this square root. There we go. Parent function is square root of x. Square root of x. And so those critical values were 0, 1, 4, 9, and 16. Again, it's okay if not all the values fit on there. We're just graphing the best we can. And my parent function values were 0, 1, 2, 3, 4. Those are my parent function y values, my f of x values. Because think about it, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and square root of 16 is 680. No, it's just 4. It's just 4. Square root of 16 is 4. We've done step 1. Step 2, is there anything multiplying horizontally inside my horizontal stuff? Inside of this absolute value stuff? Yeah, There is. -2 is multiplying, so times -2. I'm going to write that here. We're going to remember that. We're going to remember that. And I've also got x minus 1 on the inside in that horizontal business. Okay. Let's check out the vertical stuff. Well, we've got this negative just hanging out here. What the heck does that mean? Negative what? Well, if we didn't want to change it, we'd just call that a negative. Oh, it's a -1. It's a -1. We just don't write the 1, right? Just like when we have 1x, we don't write 1x, we just write x, right? So that's like a -1 multiplying on the outside. And let's see, do we have anything adding or subtracting here to make it go up or down? No, we don't. In this case, because it's a translation, to not change a translation, we're going to say +0. We're going to add nothing. When you're not trying to change a stretch, compression, reflection, it's just 1, multiplying by 1. If you're not trying to change translation, it's either up or down or left or right. It's just +0 or -0, same thing. Okay, we have done steps 1 through 5. Exact operations and vertical. 0 times -1 is 0. 1 times -1 is -1. 2 times -1 is -2. 3 times -1 is -3, and 4 times -1 is -4. Because remember, in vertical, we're doing the exact operations. And adding 0 to that, I can do that on no hands. -1, 0, I'm sorry, 0, -1, -2, -3, -4. We've got our new y values. Let's take this to the next part. It says the horizontal stretch compression reflection y-axis. We have to perform the inverse operations. That's step 7. So if I'm multiplying by -2, the inverse operation of multiplication is division. So I'm going to divide by -2. What's 0 divided by -2? Well, 0 divided by anything is 0. 1 divided by -2 would be -1/2. 4 divided by -2 is -2. 9 divided by -2 is -9/2, or you can think about this as -4.5. And 16 divided by -2 is -8. Okay, so we've done the inverse operation. It said multiply by -2, so we divided because that's the inverse operation. It says we're supposed to do -1, subtract 1, so we need to do the inverse operation. We need to add 1 to everything. This becomes 0 plus 1 is 1. -1/2 plus 1 is a +1/2. Think about that. -2 plus 1 is -1. -4.5 plus 1 is -3.5. And -8 plus 1 is -7. So once again, let's graph our parent function, which was square root of x. That's where these are. And then we called it our m of x. Our m of x, we're going to look at those values. These are my x values for m of x. These are my y values for m of x. And let's see what we got. So I'm going to graph parent function in purple. Why not? Parent function purple. This said 0, 0, 1, 1, 4, 2, 9, 4, 5, 6, 7, 8, 9, 3, and then 16, 4. I don't know if this is on here. 10, 13, 14, 15. Hey, it is. So this graph looks something like this. This is our parent function. Now we need to take and look at our transformed function. Our transformed function, oh man, I already forgot. What do we call it? M of x. M of x. Our m of x is, in this case, our x values are x and y. X values were 1/2, -1, -3 and 1/2, and -7. And our y values to go along with that are 0, -1, -2, -3, and -4. So let's plot these things. I may have just gotten in the way. We'll see. 1, 0, half -1, -1, -2, -3.5, 1, 2, 3.5, -3, -7, so 1, 2, 3, 4, 5, 6, 7, then -4, 1, 2, 3, 4. This one looks like this right there. That's our m of x. That's horribly written. Let's try that again. M of x. Ooh, that's a little interesting one. Let's see if this makes sense to what we think it should be. Let's see if this makes sense. Okay. So let's see here that we got this negative out front. We said this should be a reflection over the y-axis, and it sure looks like it's gone down. At least it's on the bottom now. It's underneath the y-axis. That's good. Well, this negative sign in here would also be a reflection over the x-axis. So we've reflected here, and now we reflected here. Hey, that makes a ton of sense. It's reflected down, then left. Or you could say, it's reflected over the y-axis and then down. We'll end up there. And we've also said in here, this should go right 1. And in this case, it's not a vertex. It's kind of that initial critical point of 0, 0. Did it go right 1? It sure did. It went from 0, 0 to 1, 0. So we graphed what we said we would. There's a lot. I get that. What I want you guys to do is the last one on your own. I am going to put the values in and put those on Google Classroom, but I want you to check those when you're done. You got this. You got this. You got this. Have a great day, night, whatever time it is, wherever you are. Miss you guys. We'll talk to you soon.